A star's grand spectacle introducing solar flares. Our sun, a giant ball of burning gas, is a source of constant activity. It's a dynamic and ever-changing celestial body. It's not just about sunlight. The sun's activity goes far beyond the light and warmth we experience on Earth. The sun also releases bursts of energy, bursts we call solar flares. These flares are sudden and intense. Imagine a sudden, intense flash of light on the sun's surface. That's a solar flare. It's like a cosmic fireworks display. These flares are powerful events, releasing enormous amounts of energy in a short amount of time. They can affect space weather and even disrupt communications on Earth. They remind us that the sun, while life-giving, is also a celestial powerhouse capable of awesome displays of energy. The sheer power of these flares is a testament to the sun's might. Solar flares are a reminder of the sun's dynamic nature. They show us that the sun is not a static object but a constantly changing and active star. They are a captivating phenomenon, beautiful and powerful, demanding our attention and study. Observing and understanding solar flares helps us appreciate the complexity and beauty of our sun. The heart of the flare. What causes these solar eruptions? Solar flares are one of the most powerful and fascinating phenomena in our solar system. To understand solar flares, we need to look at the sun's magnetic field. This magnetic field is generated by the movement of plasma within the sun. Think of it like a giant, tangled web of invisible forces. These forces are constantly shifting and changing, creating a dynamic and complex environment. This magnetic field stores enormous energy. Over time, this energy builds up, creating tension within the magnetic field lines. Sometimes the field lines get so twisted and stressed that they snap and reconnect, like a rubber band stretched too far. This process is known as magnetic reconnection. This snapping releases the stored energy in a sudden, violent burst, a solar flare. The energy release can be so powerful that it sends shock waves through the solar system. Imagine a tightly wound spring suddenly released. The sudden release of tension is similar to what happens during a solar flare. That's similar to what happens during a solar flare. The energy is released in the form of intense light, heat, and radiation. The energy, previously trapped in the magnetic field, explodes outward, creating intense heat, light, and radiation. This can have significant effects on space weather. This energy is carried by particles that travel at incredible speeds, sometimes reaching Earth. When these particles interact with Earth's magnetic field, they can cause geomagnetic storms. These flares are a testament to the immense power contained within the sun's magnetic field, a force that constantly shapes and influences our solar system. Understanding these eruptions helps us better prepare for their impact on our technology and daily lives. Not all flares are created equal. A glimpse at their diverse nature. Solar flares are like snowflakes. No two are exactly alike. Each flare is a unique burst of energy, a cosmic fingerprint of the sun's dynamic activity. They come in different sizes and strengths, categorized by scientists based on their brightness in X-ray wavelengths. This classification helps us understand the potential impact of each flare. The smallest are B-class flares, followed by C-class, then M-class. These flares are relatively mild, often going unnoticed by most of us. These are like the sun clearing its throat, a gentle reminder of its ever-present activity. The most powerful are X-class flares, which can release as much energy as 1 billion hydrogen bombs. Capable of causing significant disruptions on Earth, these flares can affect satellite communications, power grids, and even create stunning auroras. These are the sun's way of getting our attention, a dramatic display of its immense power. Each type of flare, from the subtle flicker of a B-class to the explosive power of an X-class, tells a story about the sun's behavior. These flares provide valuable insights into the sun's behavior and its potential impact on our planet, helping us prepare for and mitigate their effects. Section 4. Earth under a solar spotlight. The impacts of our star's outbursts. While millions of kilometers away, solar flares can have a real impact on Earth. The most beautiful effect? Auroras, the northern and southern lights. These shimmering curtains of light in the sky are caused by charged particles from solar flares interacting with Earth's atmosphere. But not all effects are so harmless. Strong solar flares can disrupt our technology. Radio communications, GPS signals, and even power grids can be affected. That's why scientists study solar flares to predict them and mitigate their potential harm. Section 5. When the sun stood still, a look back at the Carrington Event. In 1859, The largest solar storm ever recorded struck Earth, the Carrington Event. Named after the astronomer who observed it, this event caused telegraph systems worldwide to fail, some even sparking fires. Auroras were visible as far south as the Caribbean. The Carrington Event is a stark reminder of the sun's power. If such an event were to happen today, the disruption to our technology-dependent world would be immense. Section 6. Unraveling the sun's mysteries. Predicting solar weather in the modern age. Scientists around the world are working hard to understand and predict solar flares. They use sophisticated telescopes in space and on Earth to monitor the sun 24/7. By studying the sun's magnetic field and solar activity, they can issue warnings about potential solar storms. It's like forecasting the weather, but for space. These predictions give us time to prepare for solar storms, protecting our astronauts, satellites, and power grids from the sun's most intense outbursts. Section 7. Our Star, Our Future. The continuing quest to understand solar flares. The sun remains a source of endless fascination and study. As we continue to explore space and rely more and more on technology, understanding solar flares becomes even more crucial. By unraveling the mysteries of our nearest star, we can better protect ourselves from its awesome power and harness its energy for the benefit of humanity. The quest to understand solar flares is a journey into the heart of our solar system and the forces that shape our universe.